Hello everybody and welcome to my channel. This is Sohini from South Bay, California, and I welcome you today. So I am super happy today to bring to you the first installment of AI Concepts and Tools, or ACT. And this is where I will be inviting some of the co-authors, some of the friends and colleagues that I have worked with so far on projects to come and present some unique concepts and tools that they have found very useful in their projects. We will go over the entire concept and tool in detail so that you can then find ways of extending it to your project. These sessions are super relevant for people who are early AI or ML enthusiasts, or if you feel you're stuck in your current project and might want to know about what are the other concepts and tools that others are utilizing for their projects. So if this is of interest to you, please like this video and subscribe to this channel. So today I am super happy to present to you my friend and colleague on a very recent project, Wenxi, who will be showing you how she has used Tensorboard for high dimensional clustering and visualization. So let's get straight to it.
So today we have a special guest on our series, and today I would love to introduce you to Wenxi. And I have been working with Wenxi for about a little over 2 months now, and she's from UC Berkeley. She's doing her master's, and we'd like to know a little bit more about you, Wenxi, and your background, and let's get to the concept and tool right after that.
I'm Wenxi. I'm a master's student from UC Berkeley. Right now, I'm majoring in industrial engineering and operations research. And I'm focusing on the data science and AI related topics right now. So during the summer, I'm working on the e-commerce customer behavior prediction project with Sohini. So thank you, Sohini, for having me today. And I'd love to share what I've developed in this project to everyone. So there are a lot of differences between online and offline shopping, actually, especially for some technical details involved in the shopping process. So the online browsing history from the customers, if mined in an appropriate way, we can represent the patterns or trends over time theories that can then be representative of specific shopping behaviors. We were wondering, is there any way to perfectly visualize the prepared data to make sure that there is some existing explainable patterns in the customer browsing data? Okay. So what we are looking for is some visualization tool for high dimensional space with more than 3 features. In other words, visualization with dimensionality reduction techniques. And Tensorboard is perfect for this.
See, if we can break down this problem for people who are trying to apply it. So let's say that you are on this website. Let's say it's Target, and on Target you are purchasing some items. So what you are trying to do is you are trying to see purchase histories when people log in onto the website, and then trying to see again, are they going to purchase and make the purchase at the end of the day or not? But with the Tensorboard, what really you're here to show us is there some behavioral patterns among some people who go grocery shopping on a regular basis to Target versus those, let's say, who are going to Target to buy a SIM card or electronics, or those who are there, shopping for kids, going more to the kids section. So based off of their shopping history, you're sort of trying to understand, is there a difference in the behavioral mindset that the customers have?
But right now here, what we use for the Tensorboard is to project the embeddings to a lower dimensional space, as I just talked about. And I have some recorded videos for you to show that what we have. So we have two data sets. One is about like 2 gigabytes before we process with it, and another one is even bigger, is 14 gigabytes. So actually there are a lot of data points, have like 10 millions of data points there. And when you put it into the TensorBoard will try its best to sample the data for you. But because it's like 3-dimensional and it is a real-time thing, it has to sample the data size. Okay, so this is the 14 gigabyte data set we are looking at. This is about the electronics products customer browsing history data. And after we found our features before the selection, you can see that here it has 36 dimensions, which means we have 36 different features here. And the points are like a lot of points, 1 million points here. So after a lot of iterations, you can see there is still a mess. So not very previous patterns or clusters, which means you cannot see different customer behaviors in this one. So this is before we do the feature selection.
Okay.
But let's have a look.
Looking at before and after you've done your feature selection or feature engineering, right? So before we were not able to see any clustering, but then we wanted to point out that we were looking at the TSNE dimensions and not the PCA dimensions, right?
Yeah, exactly. So TensorBoard provides different ways to do your dimensional reduction, and you can choose the PCA here, but we just found that if you do the TSNE, which is a newer and like better dimensional reduction way, it just give a better result. That's why we are using this. So this is what we do after we do the feature selection. So right now here we only have 8 dimensions of data, which means we have 8 good features here, and you can see that it's very obvious different clusters between the customer data. So maybe each of the clusters will stand for one kind of different customer. They may buy or not buy things. They may have a long browsing history or not. So this is what we have. This is very amazing.
So what can you walk us through what the blue dots mean versus what the red dots mean here, Wenxi?
Sure, no problem. So actually, you can use this color map for your labels. There are two data sets that you can upload for this. Afterward, I will walk you through the basic code for the TensorBoard. So one is called the feature data. Another one is called the metadata, which is for your label color. So here, the blue dots stand for the customers who do not buy the things eventually, and the red dots stands for the purchase events. So you can see that there are way more blue dots over the red dots. So TensorBoard is actually very easy and friendly to use. What you have to do is just import some of the libraries, including the TensorFlow and the TensorBoard plugin, the projector function, and also if you want to process your data a little bit, you may want to import the standard scaler and the PCAs. It's actually, you can combine the PCA as well as the TSNE. So you can do some PCA before you TSNE in TensorBoard. And here it comes the data. You can rate your data points as well as the metadata, which I just mentioned is for your label color. So because what we do for TSNE is totally unsupervised. If you don't have the metadata for the label, it's totally okay. It's just that you don't have the colors, different colors for the labels. After that, here I did some PCA, but if you don't have much of the features, that's fine. You skip this step. And also, one thing I want to mention is that there are two versions of TensorFlow for now. There is version 1 and version 2. So some differences are between them. If you want to figure it out and use the right version, you have to see your code yourself. There are a lot of tutorials on site. So you have to get the TF variables with your data. This is what I have after PCA, and do it as to assign it to the embeddings. For this one, you can just find the code base online, and it's very easy to run. After you run it for like only 1 sec, you can then open your Tensorboard. So you can just enter this line of your code here with the log dir of yourselves, and add the ports is equal to 6006, because sometimes if it doesn't work, you can just add this one. And this one should be run in the bash or git or your terminal. And so after that, you will get a localhost website, and that will give you like the dashboard, what it has. So this is about a code to lead you to the Tensorboard. The other way is to just log into this website, the projector.tensorflow.org, and there they will ask you to upload your data. So you can load your data here, and just pay attention that you have to load a TSV file for the vectors, as well as the metadata, which will give you another dashboard for your data points like this. So both of the way around.
Some closing comments as to how you think people can utilize this for their project.
If you are aiming to find what exactly the clusters are and which of the data points fall into each cluster, you'd better to import the algorithms, for example, the PCA, TSNE from TensorFlow to store the results. So Tensorboard is a visualization tool.
So it's all for visualization. This time it was the data dimensionality reduction. Maybe we'll have you again, Wenxi, for looking at some of the ways you have used Tensorboard other than just visualization. So thank you a lot, and I hope people get inspiration to utilize this a little bit more. And stay tuned for our next installment of AI concepts and tools. Thank you.